Hey, welcome back to Fat Mama Physics. In this video, we're going to talk about subtracting rational numbers. Since this is a new lesson, we will first introduce a board game like I would do at the beginning of every lesson. So, before we get started, subtracting rational numbers is basically taking away either fractions, or you can take away integers. And really the one I want to focus on is subtracting something that's already negative. And this concept comes up again and again a lot when we talk about subtracting integers, but also very important when it comes to rational numbers. So let's start out with the game. So let's just turn it over here. Okay, this is the game that we have today. This is the current game that my husband and I are playing right now as of whatever the date of the release of this video is. It's Gloomhaven, Jaws the Lion. Gloomhaven, the game itself, the original board game is twice as big, if not much bigger than this one. This one is a shortened version, but very much gives you an idea of what the campaign feels like. So also, we are having lots of fun with this one. So here's what it looks like. Here's kind of my setup, and here's my characters and whatnot. So the idea here is a campaign. You and a player or so. It's me and my husband. We can go up to 4 players, but we just decided just to play between ourselves because it's a campaign, it's a cooperative game, meaning that you can't really introduce new people. It will be harder to introduce new people if they decide to come into the game. So here is the map of the city, Gloomhaven, right there, and basically there's a lot of missions and all sorts of evil happening in the city that we have to conquer. Since we're mercenaries, we like to find jobs and get our pay. That's kind of what we're doing. And this is the tutorial. This is actually one of the tutorials scenarios. And we're coming in here. Here's I'm this guy. Oopsie. I'm called the Hatchet. I don't know if that's a spoiler. That's probably some sort of a spoiler. And my husband is, he's a demolitionist. Demolitionist does a lot of obstacle damage. Notice the green boxes here, they're obstacles, which you can't bypass them unless they are destroyed. I am a Hatchet. I'm kind of I'm a bit of a tank, but I deal more range damage. I throw axes around, essentially. And yeah, that's kind of I enjoy playing ranged characters and like to snipe people while sitting at a spot. That's kind of my what I like here. And the cool thing about this campaign is that as you level up, there's new surprises. You get to open up character upgrades, which I don't know about these. Actually, I do know about these, but at this point you wouldn't. And there's new things, new monsters at every stage, and always new boxes to open. The bigger game also has more surprises there. At the end of each game, I level up or I gain certain items. Here are the items, nodes, gold nodes, XP nodes, my levels, and perks, okay? And of course, at the beginning of the game, you don't start with that many items. This is kind of my setup now, which is relatively mid-game-ish. This is just the first scenario, so this is a bit of an overkill. And the idea is, what does a round look like? So notice there are monsters, and there is you, and here I also have my set of cards, which are my attack cards. So at the beginning of a game, I would pick 10 of these. I'll just take 10 at random. Okay, I'll just take a bunch at random. And at the beginning of every turn, what would happen is I would play 2 of these cards. Not a lot of space on this table, but let's say I play these 2 cards, and notice that with these 2 cards, I would choose one action on the top, one action on the bottom. Usually the bottom is move, and the top is some sort of attack. The other thing we want to look at is these two numbers. These are the initiative numbers, meaning if you have a smaller number, you go first in a turn order. You pick one of them, and I like to go first. I usually like to get my kill early, so 15. It might be strategic to go a little bit later for the monster to maybe move closer to you before you start the attack, but that lends itself to less control. So anyhow, that's my initiative. So my husband or whoever I'm playing with would do the same thing, and the monster here, which are called Vermling Raiders, they would also make their move. And this is their deck, and it's randomized, so they do this. They do whatever this attack is, and that's their initiative, so they go at number 36. If my initiative is 15, I would go before them, and depending on what the demolition has, he would go after or before me, and so on. And so what happens is that these characters, they move along, they do some damage. So let's say I'm not gonna move because I can just range this guy with he is 3 hexes away, 1, 2, 3. So usually I have the range to be able to do some damage. And let's say I do some amount of damage here, which maybe be, let's say he's number 2. So this is the damage tracker, okay? And now here's, let's say I do 3 damage. So this damage here, even though it says 3, it's actually -3 to his health. And that's where I want to talk about subtracting rational numbers, is here I have a -3 damage to him to his health, so he has 3 less health. Now this monster here does not have any healing abilities. I don't think he does. No, there's no healing abilities. Some monsters later in the game have the ability to heal. And what would that look like is they would take this damage marker away, meaning that they have healed themselves. Or let's say they heal 3. If they heal 3, they take this damage away. So it's like subtracting damage on the monster, which allows it to heal to regain its health. His health actually, his max health is up here, which is 5. The 10 is for elite monsters, so we don't worry about that. We just worry about the base monster. So he has a health of 5. If I deal 3 damage to him, then he would be at a health of 2. Let's say he's able to heal. If he heals 3, then we subtract -3, which essentially is adding 3 to his health, which is currently 2. So if he heals 3, he takes away the damage, he then is at full health now, okay? So then that's kind of what it means to subtract a negative number. It's the same thing as adding that number, or you can think of it as the situation is getting better, so 2 negatives make a positive, okay? So that's the idea of subtracting rational numbers. It doesn't matter if you're subtracting fractions or decimals, the idea is the same. Okay, so I'm going to leave this game now. There's so many cool things about aspects of this game, which I'm not going to go into detail with, but here we go, Gloomhaven. Time to pack up this game. Alright, so here we have, we're back to our lesson now, subtracting rational numbers. Let's take a look at how that applies here. When you have, if you're subtracting a negative number, what does that mean? So let's start off with some examples with a quick review. We have 9 minus 12. It's like you have $9, but then you have to take away $12, and there's no more to take away. So if you have to take away 3 from 0, you're going to have to be left with -3. So you're in debt of $3 if you actually have to pay $12. You owe somebody $3. Okay? So the easiest way to do this one is just to say 12 minus 9, and since the negative is attached to the 12, that 12 is going to be larger, and the sign in front of the larger number is going to take precedence. So slapping that negative number down at the end. Okay, now we have B. We have -12 minus -8. And like we just saw before, if you're taking away damage, you're actually healing yourself. So that's a good thing. And it's almost as if you're healing damage, you're adding health points to yourself. We're just talking about Gloomhaven. So here, -12, this is like adding 8, and -12 is still bigger than +8, than 8 itself, so I'm going to be left over with -4. Okay. All right, now I have 9 minus 12. This is the same as me adding 12. Again, it's like healing 12 damage, which is great. It's 9 plus 12 gives us a total of 21. So very nice large number. Here we got negative 12 minus 8. And again, if you're taking away a positive number, it means you're just subtracting it. It means exactly the same thing. So minus 12 minus 8 gives us a total of negative 20. Double check I did my math correctly, and we move on. Okay, so when we deal with integers, that's kind of what we're doing. But with fractions, everything is still the same, except you just have 1 or 2 extra steps. The 2 or 1 extra step include, first of all, you need to make sure your fraction is not in mixed number form, but in improper fraction form. The second thing you have to make sure is that you need to convert these fractions so that they have the same denominator. So let's do some examples. I may ask you midway to try some yourself. Let's start with A. And A is nice because you don't have to deal with any mixed numbers. You just have to make sure the two numbers have exactly the same denominator. To make sure they have the same denominator, you take a look at the bottom here. There's a 6 and there's a 3. The easiest way is to look at what the greatest common multiple is, and that's going to be your common denominator. And since 3 and 6 have a common multiple of 6, that's going to be my denominator. So I'm going to rewrite this here. I'm going to write these two as fractions over 6. The next thing I need to do is to figure out what I need to multiply the top and bottom by to give me the denominator and the numerator, or to give me the common denominator. For example, the first fraction, I don't need to multiply anything to give me 6. Technically 1, but 6 times 1 is just going to be 6. 5 times 1 is just going to be 5. So that's the top. For the second number, subtracting 3 over 4, I need to multiply 3 by 2 to give me the 6. So I need to multiply the top by 2, which then gives me a total of 8. Then what's going to happen next is I'm going to keep my fraction the same, and essentially you just do just add or subtract the top, the numerator, which is 5 minus 8 in our case. 5 minus 8 gives us negative 3 over 6. And guess what? We always need to simplify our fractions or our answers to the simplest form, or to which in this case we need to divide the top and bottom of our fraction by exactly the same number to treat the fraction fairly, and so we don't change the fraction. 3 divided by 3 is going to give us the simplified answer here, which is going to be negative 1 over 6 divided by 3 is equal to 2. Our final answer is negative a half. The good idea to always box your answers at the end, okay? That's A. Not too bad. Well, let's take a look at, guess what? I'm going to do B because it involves a mixed number, and I think you'll be able to do C and D. So let's do B very quickly. Now that we have a mixed number, we have to do something first before we choose the common denominator. We need to first convert this to a improper fraction, which gets rid of the whole number 1 and puts it into the numerator. So here we have 1.5 pizzas. So every pizza here, if I divide it into halves, I'm going to get 2. So that's like saying 1 times 2, which is going to give me 2, and then plus 1, that was the other part of the pizza, okay? So my improper fraction is going to be 1 times 2 is 2, 2 plus 1 is 3 over 2. That's my improper fraction, okay? And I'm going to subtract whatever this is, and you know what? If I subtract a negative fraction is exactly the same as adding that fraction. So I'm going to add 1 over 4. Now we're in the same situation as question A. We just now need to make sure that they have exactly the same common denominator. Now, between 2 and 4, the lowest common multiple is going to be 4. So I'm going to write both fractions out of 4. Okay? The second fraction, I don't have to change at all. It's just 1 over 4. But the first fraction, I needed to take 2 times 2, which is going to give me 4, and 3 times 2 is going to give me 6. So I now have 6 plus 1, that's 7 over 4. No need to simplify. It cannot be simplified anymore. This is 7 over 4 as the final answer. Okay? So you know what? Here's a good time. Let's see, what should we do here? You know what, if you can do all the examples, C all the way to F, great. But let's just do 2 at a time. So good time to pause the video and do C and D. Good time to pause the video. Okay, so hopefully you've tried C and D, or if you are stuck, that's why you're watching this part. Okay, so number C, again, we have a mixed number. We need to convert into an improper fraction. So we're going to do that first. I'm still going to write the first fraction out, which is negative 5 over 4. And here I'm subtracting a negative. That's exactly the same as me adding that fraction. So I can just take care of that negative right now. And to get your improper fraction from a mixed number, I take my 3 multiplied by 5 is 15, plus the 1 gives me a total of 16 over 5. Now we need to find the common denominator, which, if we take a look at the lowest common multiple between 4 and 5, it's just 20. And you're thinking, yeah, I just multiply 4 with 5 to give me my lowest common multiple. Sometimes that's the case. So let's do that with our fraction below. Okay, so 4 times 5, that's going to give me 20. So I'm going to have 2 fractions that are going to be out of 20. The first number is in fact negative. And to give me 20, I need to take 4 times 5. I will do the same to the top as well. 5 times 5 is 25. My second number is 5. That multiplied by 4 gives me 20. I multiply 16 by 4 is going to give me 64. Okay? And that is enough for us to do the adding and subtracting. So my total final fraction is going to be out of 20. And here I have negative 25 plus 64. Negative 25 plus 64. I could also just take 64 and minus 25 as well. That's exactly the same idea. So if I did that, that's going to be, let's see, 64 and 25. That's going to give me 939. Okay, so 39 over 20. And let's see, can we simplify this? No, we cannot. 20 cannot be divided into 3s. That is our most simplified fraction form. You might be wondering, Miss Lee, do you need to convert this to a mixed number for you? No, I don't need you to convert your improper fractions to mixed numbers, maybe contrary to what your teachers have told you before, because improper fractions are more practical. They are easily handled, used in future questions in case there's parts A, B, and C in your answer. So there's no need for you to convert them to a mixed number for me. Haha, lucky you, one less step for you. Okay, moving on to question D. Oh, well, guess what? B was also an improper fraction, so I forgot to tell you that. Next up, we have another two mixed numbers. Again, let's convert them into their improper fraction form. 2 times 2 gives us 4. 4 plus 1 gives us 5. 5 over 2. We're going to subtract this mixed number. 4 times 8 is 32. 32 plus 7 is going to be 39. 39 over 8. So again, we need to find the lowest common multiple between 3 and 8 to give us our common denominator. Well, guess what? 2 times 4 gives us 8. So 8 is definitely our lowest common multiple. 2 numbers subtracted and out of 8. Let's take a look at the first one. 2 times 4 is going to give us 8. Therefore, if I multiply the top by 4, I'm going to get 20. This number here doesn't change because I still kept it out of 8. I'm going to get this one, 20 minus 39. What that looks like is 20 minus 39 on the top for my numerator. And then my denominator, I keep it as 8. Okay, so if I subtract this 2, I am going to get negative 19 over 8. And there's no way to simplify this, therefore I just box my answer, and that's it. Next up, we have E and F. So here's here's the deal. If you got C and D correct, and you're free to try E and F by yourself. If you struggled a bit, maybe you might want to watch this through with me. But again, I'm going to give you another chance to pause the video and try E and F. Okay, now I will go over E and F with you. With E, again, I need to write all of these fractions in improper fraction form. So if I'm subtracting this mixed number, again, I take the 2 times 8 is 16. 16 plus 5 is going to give me 21 over 8. I need to find the most common denominator here, and the lowest common multiple between 4 and 8 is 8. So I'm going to have these two fractions out of 8. To give me my 8, I need to multiply 4 by 2. Therefore, I do the same at the top. So I'll have 6 over 8. The second number, I didn't do anything. So I just keep the numerator at the top over there. Next up, I subtract the two numbers, 6 minus 21 over 8. And after I put these together, I am going to get, this is exactly the same thing as negative 21 plus 6. Either way, I am going to get negative 15. Can negative 15 over 8 please simplify it even more? Unfortunately not. So if you left your answer in this form, great. Okay. Next up, we have F. Again, two mixed numbers that are subtracting one another. We need to first convert them to improper fraction form. Don't forget the negative sign in front. A lot of my students will forget that. 2 times 8 equals 16. 16 plus 3 is going to give me 19 over 8. I got the negative sign already, so don't forget about that. So 3 times 2 is 6. 6 plus 1 is 7. 7 over 2. And oh my goodness, all these fractions here, we don't need to multiply both of them, because the lowest common multiple between 8 and 2, it's just 8. Somehow the questions are rigged in that sense. So I have negative, and this fraction will be out of 8. The second fraction is going to be out of 8, so we need to figure out what is multiplied by, what multiplies 8 to give us 8, which is 1, and which means I'm going to keep the same for the top in our first fraction. The second fraction, I need to multiply this by 4, therefore multiplying the top by 4, giving me 28 at the top. After I add, or actually, I'm subtracting these guys, so I have negative 19 minus 28 all over 8. This is going to give me negative, this is going to be 7, and this is going to be 4, all of this over 8, and this cannot be simplified even more, and so I'm going to leave my answer in this form. So here you go. This is pretty much subtracting your rational numbers. Okay, this is the first page. Okay, we have part 2 dealing with decimals and a word problem. So thank you for watching, stay tuned, and see you next time on Fat Mama Physics signing out.